You are live. Okay. Okay. You guys shut the door. Okay, thanks. Yeah, sneezing. Okay, here we go. So we're talking about chapter 4. Yeah, you can see my screen? Everybody's okay here? Nice. So we're talking about chapter 4. I keep losing my screen here on my RGB. I'm losing my reds on my monitor for some reason. It's kind of like we're in the future. And outer space, maybe, from Mars. Oh, I can't do anything about it. There we go. So chapter 4, we're talking about applications of derivatives. So when you see this word in the math class, what do you, besides the groaning, what are you thinking about?
Suicide.
What?
Because like application is like the problems that we need to read the big text and print the
Yes,
problem.
exactly. Word problems. Exactly.
Oh yeah, I was right.
Yes,
Suicide.
yes. So there are a bunch of, there's a couple of sections that are very, very wordy. Okay, but what I try and do in those sections is really strip them down to a few basic problems. So you'll see on all of my chapter 4 tests similar problems, and the same will happen for you. So when things get really complicated in chapter 4, I will reduce the type of problems I'm going to give you. Okay, and when things get really wordy, and they will when we're writing up solutions, I will really spoon feed you exactly what you need. I got you, man. I will spoon feed you exactly what I want you to write, and that you will put all that on your formula sheet, so it's not you know it's not going to be difficult, even though the amount of work is difficult and some of the wordiness is difficult. I'm going to try and simplify everything for you. There's several things in here that I can jump around with, and some I could even skip. Okay, so but we're looking at 4.1 related rates. I don't usually do that first because it's a little tricky. 4.2 is absolute min and max. 4.3 is the first and second derivative test. And we did most of this already, believe it or not. Uh, 4.5 is, I think, L'Hopital's. Let me just double check. Yes, so we did that already. There's an optional S there. So we don't have to do that. That's kind of nice. 4.4, why did I skip that? Because I always skip it. That's why. 4.4 is graphing. So I'm not going to bother doing the graphing because...
Whoa, you can graph a math function.
Yeah, well, it's supposed to be us graphing everything without a calculator. But since we're using a calculator, we'll kind of pretend that you don't know how to graph without a calculator. Or whatever, I mean. 4.6 is optimization. And I think that's it, because 4.7 is our project. 4.7 is Newton's method. Yes. And that's where we're starting today. We're starting in 4.7 because it's your project. It's due the day of the final exam. So on the day of the final exam, when we meet, I think we meet at 8 a.m., right, for 2 hours, you'll have turned that in to me, right? or right before the final exam begins, I'll say, well, last chance to turn it in. Now, your current grade has your project in as a perfect score. That's 10%. Is that what I counted the project as? Yes, 10%. That's a huge chunk of free. So don't skip the project. If you want to skip the project, just take 10 points off your current average. Right? So if you have an 83 and a B right now, and you don't do the project, you'll pretty much have a 73. Okay? So again, it's a little weird to calculate the grades right now without the other tests in the final, but I try to do my best to give you a rough estimate. Yes, Alan, I posted. Can someone verified already that I posted the test 3 solutions? Yeah. So I think they're in an announcement. Okay, so what we're doing today is Newton's method. It's very cool. I have posted the project file. Can you make sure, all of you make sure that you can see that on Blackboard? There's a new project folder on the left-hand side of Blackboard with the project instructions and a little checklist of make sure you do these things, right?
Yes.
A rubric, okay? And the rubric was written for when I was face-to-face, so, you know, obviously you don't have to staple anything. You're gonna do a PDF, you know, kind of thing.
Virtual staples.
Yeah, exactly. You're gonna use technology. You're probably gonna have pictures from graphs. You're going to have tables from Excel. And so you're going to just kind of piecemeal them all together. I don't care if you print it and tape it together and take photos, or if you actually use Microsoft Word. I don't care. I don't want you wasting time on stupid things. You know, changing the font size. Don't waste time. Right? You can certainly handwrite it. I don't mind at all. Just want it to be neat, right? Right? And it's going to be sent in as a PDF in order, and it's going to read. It should read well. It should read like you're a mathematician. It should read like a biolab, right? It read like a book report, whatever. So you know, take care of it and work on it. Now, I'm going to give you Friday to work. So you have this Friday. You can do this whole project now, okay? After today's lesson, anyway. So you have this Friday. We will not be meeting. You have the class time to work on the project. Do you have to? No. I can't control you. You know that. I can't control anyone. And you can work in the project in a group of 3. So you can work on it alone. You can work on it in a group of 2. You can work on it in a group of 3. You cannot be more than 3. Okay. If we take a look at the project right now, let me open it. Oops, sorry. Trying to open it anyway. There it is. So I didn't write the project. If you're savvy, if you're internet savvy, you could find the solutions. But in my rubric, I asked for a couple of other things. Okay. So, but it'll be good for you to do it. This is, I mean, when you press square root of 2 on your calculator, the algorithm that's built into the calculator is this exact algorithm. So this is a computer science major's dream, to think about what is the program running my calculator, right? And when I press pi, how is the calculator coming? Does it just have it memorized? No. It's going through a little algorithm, right? That's generating how many digits you want in pi, right? Same thing as square root of 2. So anyway, we start talking about This stuff is all theory. There's nothing to do in this first part of the project, not till you get to part A. Okay, so then you're doing these following activities. Now, when I talk about Newton's method today, I will be basically repeating what it says on that first page. Okay, but in my language, in a little bit of an easier language. Okay. So part A and B are very similar. Part C is when you first start using Newton's method. So part A and B are you coming up with Newton's method. And again, I'll explain that. And D, we're going to calculate the reciprocal of pi. Of course, you can do 1 divided by pi on your calculator and get the answer. So know where you're trying to get to, right? And part E is the tricky one. That's algebraic. So you just want to write yourself a little note that part E is all algebraic. Don't give me numbers. Just manipulate the algebra, okay? And then part F is the reason why I've got a maximum of 3 students working together. Because if you do this project alone, you only have to answer 1, 2, or 3, only one of them, right? Does that make sense? So if you do the project alone, just answer one of these 3. If you do the project in a group of 2, each of you should answer one of the 3 separately, right? So if one person does part 1, someone else should do part 2 or part 3. If you do it in a group of 3 students, you're all going to answer each one of these separately, right? Does that make sense at all? Now this is, and there's 3 examples here. They're all different, but Newton's method fails in all of them. Okay, you don't know what Newton's method is yet, but it fails. So you're just going to discover kind of in these 3 questions here. Only one of them though, right? Why Newton's method fails in that particular instance. Okay, and that's the project. I think you can do it in 2 hours. Especially after you see me talk about it, okay? So here we go, Newton's method. So what we're trying to do is we're trying to find zeros, right? Or better yet, solutions, right? Solutions. Like if I say to you, y equals x minus 2 times x plus 3, right? You can see I have a 0 at 2, right? You with me there? So 1, 2, 3, there's a 0. 1, 2, there's a 0, right? We know it's doing something like that, right? Yeah. So Newton's method is trying to find a 0 for this thing. And of course, if it was written out, right, what would it be? X squared plus x minus 6, right? It's hard to see what would make that 0 instantly, right? But that's what we're doing. We're trying to find zeros, right? So if I say to you, what's the square root of 2, right? I might have a function like x minus square root of 2 equals 0, and I'm trying to find that answer, right? If I'm trying to find the reciprocal of pi, right, I've got x minus 1 over pi equals 0, that kind of thing, right? And you'll see this one in the project, okay, in the project itself. I think it was part D. We're trying to find the reciprocal of pi, okay?
Wait, wouldn't a function like x minus 2, x plus 3, that just be zeros, negative 3, and plus 2?
Yes, but in this case, it's very easy.
I see.
In this case, not so easy, right?
Yeah.
Yeah.
A little bit more tricky.
Yeah. So in this case, but what I'm trying to do is trying to demonstrate to you what Newton's method is doing here. So what we're going to do on Newton's method is we're going to find an initial guess. And most of the time, right? Uh, it'll be obvious what your initial guess should be. All right, so for like 1 over pi, what is 1 over pi? Somebody give me the first couple of digits.
Let me see.
1 divided by pi equals. So 0.3183, right? Anybody else seeing that, the reciprocal of pi? Yeah, so a good initial guess would be 0.3. Does that make sense? I mean, it should be obvious what the initial guess is, right?
Yep.
So use your calculators to get an initial guess kind of thing, right? Or just guess and see what happens. In fact, at one point in the project, you'll be starting with 2 different guesses, and one will work and one won't. Go ahead, Afsu. Good morning. Thank you.
Good morning. This may be an odd question. I always thought like pi was 3.14, like the first 3 digits at least.
Yes.
So why would it be?
Yeah, I'm doing the project's going to ask for the reciprocal, the upside down, 1 over pi.
Yeah, but wouldn't it just still be like 0.3.14? I mean 0.314?
No. If you did 1 divided by 3.14, you'd get really close to my number.
Okay.
So this is a reciprocal of pi. Yeah, just do that, and you'll see you don't get 3. I mean, 1 divided by 3 is going to be some kind of 3, right?
Mm-hmm.
Right. So they look kind of similar, but so make an initial guess. Find an initial guess.
1 over 3 is 3 repeating.
Yeah,
0.3 repeating.
Right. 0.3
So
repeating.
it's because the reciprocal function they do some funky things.
Oh no, because just divide. What do you mean?
Well,
Just
yeah.
divide. Okay, so we make an initial guess. Okay, so let's say my particular guess was something like x equals 3.5. Okay, so I guessed here, right? Does that make sense? What I'm saying? Right. So I said x is 3.5, and of course I plug it into my function, and it doesn't give me a 0, so I didn't guess right. Right? Does that make sense? I make a guess. I put it into the function, and I see what I get. All right, I didn't get 0. I got some positive number. So what I do is up here, I draw my tangent line, right? And you can see, so we know how to get a tangent line, right? We take a derivative, right? We use points, we get the tangent line. But then look at where the tangent line hits the x-axis again, right? So this was my initial guess, right? So this is, I'll say x sub b, and I got a y sub b, right? So x sub b is my initial guess. I'm just going to use the letters a and b, okay? I think I use a lot x next. I like to use the word x next. So my initial guess, I like just an x, and then my next guess is my x next. Yes, exactly, Jesse. So look at where my tangent line hits the axis. Right? Do you see it? That's my x next. So right where it hits the x-axis, that's my next guess. And then I'm going to rinse and repeat. So I make a guess, I get the tangent line, I find where the tangent line hits the axis, and I see if that one is my 0. And if it's not, rinse and repeat. It's that simple, right? And you can kind of imagine, right? Let me just exaggerate this line a little bit, okay? You can imagine, right? Here is obviously my 0, right? Yes, everybody with me? But if I guess out here, right? And then I draw my tangent line, then you can see my next guess, right? So this is initial guess. This is my next guess. And then I draw my tangent line again. And let me not make it happen that quick, right? And then there's my next guess, right? So you can see on this particular curve, when the curve behaves very nicely like this, it's going to just keep getting closer and closer to the zero, right?
This is basically like what if we were teaching chapter 1, it's like, or some of the really early stuff in chapter 2, where
Yes.
it's like guess and check.
Exactly. Yeah. Yeah, you could eventually just do a limit here, right? It's definitely getting closer to that zero, right? So we understand what's going on here with Newton's method? Kind of? All right, so think about my points. What if this was right? What if this was my initial, I'll say x initial, y initial, right? And this point here on my tangent line, so let me just get back to my single tangent line here. Here's my single tangent line, right? So I guess an x initial, right? And then this point is what? Well, I'm going to call it x1, y1, right? Because it's my next guess, right? So if I start at 0, my next one is 1. It's kind of a computer science thing. Start counting at 0. Or physics, too. We always say the null or the initial velocity, that type of thing.
What is our function that we're working with right this second?
The tangent line, right? Remember, this purple line is my tangent line.
No, like the overall...
Doesn't matter. Doesn't matter.
Okay.
Because we're going to change the function, right?
Okay.
Yep. So how do I get this tangent line? Someone tell me.
We can use MSEC.
Yes. But we know this tangent line, right? What's the slope of this tangent line?
Its slope is it like y1 minus y0 over...
Yeah. Better is f prime of x naught, right? Do the derivative, right? You're right, Marcus. We could do it that way, but we want to be thinking of... Remember, we don't know where it's hitting the ground yet. We have to find where it's hitting the ground because that's where our next value is, right? So we don't know this yet. Does that make sense? We only have a tangent line, right? And we know how to find a tangent line at one point, right? No problem. Is everybody with me?
Okay, I got it. A little bit.
Pedro. Okay. Yeah. So what can I say here? What do I know? I know y minus y initial equals f prime of x times x minus x initial. Everybody with me there?
So far.
Good. Notice I used, this is f prime of x initial, right? That was my guess. Notice where I used my initial guess from. Now, how do I find y initial? How do I find y initial?
It's just like our finding our mx plus b, our tangent line formula. We go back to the original point.
Okay, but I put it in the function, so f of x initial. So notice my initial guess, x naught, x sub 0, right? And I know the notation is hideous so far, but it'll get better. Everywhere I plugged in x initial, it's all coming from my calculus, my tangent line, right? So my original function, my derivative, what am I trying to find here? What of this is unknown? What of this is unknown?
Is it like the equation line?
So the whole thing is the tangent line, but what part of it don't I know yet? I couldn't put this in Desmos. I'm pretending I know the function. Of course, I know how to get to
We don't know our function yet.
Well, no, let's pretend we know the function.
Okay.
What piece don't I know yet?
X0.
No, X0 is my initial guess, right?
Oh, we don't know our target. We don't know our destination.
Exactly. So what is that?
I mean, you could say like X0 prime. I don't know, like
yeah,
whatever
I
number
labeled it.
is
I labeled
required
it,
to get 0.
I labeled it X1, Y1, right?
Okay.
Okay. So X1, Y1, right?
We need the limit as X0 approaches X1.
Good. What don't I know? X1. What do I know? Y1. Say yes, everybody.
Okay. Because it's 0.
It's 0, exactly. So,
okay.
So negative f of x naught, the initial guess, equals the derivative of that initial guess times the unknown. I'm just going to call it x again because I don't like all the subscripts, right? I'm just going to call it x again. I'm solving for x, right? This is my x next, I like to call it. Solve for x. This, by the way, what I'm doing is the first part of the problem in the project. So I'm basically doing it for you, right? So, so what do I want to do here? How are we going to solve for x here? Well, I could distribute or I could divide. So I'm going to divide, right? So I get x minus x naught equals minus f of x naught over f prime of x naught. Right? Everybody with me? I just divided by the derivative, right? The derivative evaluated at my 1 point, right? Who is that, Gerber? I got you, Gerber.
Sorry.
Okay. Oh, that was Jesse. Thanks. So now I can just add x naught to the other side. So x next is equal to the initial guess minus the function evaluated at the initial guess divided by the derivative evaluated at the initial guess. And this is Newton's method. And I'm going to iterate, right? You understand iterate. Once you get an answer, put the answer back in, right? It's like rinse and repeat, I like to say. That's why I won't buy conditioner anymore. I bought, every time I buy it, I run out of conditioner the same day because it just says rinse and repeat. It doesn't say how many times. So there it is. There is my Newton's method.
So getting from our step 0 to step 1, you divided x0 by x and divided by x to get that form where it's negative f of x0
so from this line, I divided by f prime. Right? So on the right side they cancel, on the left side they, right?
Oh, okay.
Yeah. And then I just added x naught, right? So this is Newton's method. So I want to iterate with Excel. Okay, you can use something else if you want. If you want to use, what is it called?
Oh, so really the left became the right at the end.
Yeah, I switched sides. Yeah.
Okay, that's why I was confused.
So I want to iterate using Excel. Okay, and so you can paste your table in. You could certainly attach your actual Excel file to the project, you know, but you certainly want to show me the table in the project when you do it, how it's going from answer to answer. Let's look at the very first actual problem that you do when you're calculating, and that's part C, okay? So part C is the first thing I do when I'm calculating. So once again, everything they're doing is what I just did, okay? So read it again, read what they're saying, answer their questions, right? So here's my equation. 1 over x equals 1 plus x cubed has one positive solution. So 1 over x equals 1 plus x cubed. And of course, I mean, I know how to graph this, right? 1 over x looks like this, right? And 1 plus x cubed looks like this, right? So we're after this solution, right? There, that's my question mark. I'm trying to find where they cross at so one positive x value, right? So I certainly can do this on my calculator real quick and get an estimate. Where's my calculator? So we're trying to get an answer on it. Go ahead, Hudson.
How do we know from the formula right there that we're only looking for the positive?
It says it in the. So I'm reading part C. The equation 1 over x equals 1 plus x cubed has one positive solution. Yeah. Yeah. So reading, I know reading sucks. I know it does. So I'm using my calculator. Oh, I guess I should do it on my computer so you can see me do it. But you should be doing this right now. So I'm using. My God, my desktop is such a mess. I'm using my calculator here. And y equal, I'm putting 1 over x. And y1 and y2, I'm putting 1 plus x cubed, right? And if I look at the graph, I can see that one positive solution there. And I'd like to zoom, I'll zoom in on that a little bit. Zoom 2. So what do you think's a good guess here?
Well, you can use calc.
Yeah, absolutely. I can use the calc button.
Calc intercept.
But just looking at what x value is pretty close to this thing, what would you say is a good guess?
Like 0.7 for the right
Yeah,
one?
sure,
Like
sure.
0.7,
Exactly.
Negative 1.3.
So you could just go right to Newton's method with 0.7. Let's actually find the answer here. I go second, calculate intersection 5, and then I just hit enter, enter.
I did the right one already.
Oh yeah, what'd you get?
It's in the chat.
Oh, thanks. Nice. 0.7244. Beautiful. So 0.7 is a great guess. So that's what I'm going to do. Right? Now, I want to simplify this function a little bit. So I want to turn this into a function. So I'm going to call it f of x equals 1 plus x cubed minus 1 over x. Right? And now I'm looking for the 0. Right? You see? If I move this, when these two sides are equal and I move one to the other side, I'm going to get a 0 now. And that's what Newton's method does for me. It gets me a 0, right? What time is it? Oh, I'm good. So remember what I need for my Newton's method. I need x next, right? I need x. I'm just going to I'm going to get rid of the subscripts because it's a pain, right? So I'm just saying I'm looking for my next x value, right? So I'm just going to use x. I'm going to use x minus f of x over f prime of x, right? Yes, you with me? And I want to make that look as pretty as I can, right? So look at what I'm doing for x next now. Well, I'm going to have an x. I'm going to have negative 1 plus x cubed minus 1 over x divided by the derivative. What's the derivative here?
There's going to be a 1/2 over x squared.
It's going to be a
1 over
3x squared,
2x squared,
right? 3x squared, right? Minus plus what?
Plus 1 over 2x squared, right?
Nope.
I think.
So I need a derivative, please.
X.
What is it?
1 over 2 root x?
Nope.
For derivative of 1 over x?
Yes. Come
It
on.
should just be 1. It's just 1 over 1.
What?
Oh, it's
Wait,
1 over x
hold on.
squared. 1 over x squared.
1 over x squared, thank you. So I got 3x
We were all messed
squared
up.
plus 1 over x squared.
I wanted to do it in my head.
I was going to say, who taught you Calc 1? Who taught all of you Calc 1? So there's my x next. I want to make it pretty. Okay? So anybody have a suggestion for me?
Delete the one of delete one of the 1 over x's on the bottom, and then it's just minus 1 on the top.
Clear fractions with x squared over x squared. So I've got x minus x squared plus x to the 5th minus x over 3x to the 4th plus 1. Everyone agree?
That's a slightly different way to LCD it.
Easier. That's why I've been doing it all semester.
I see.
What else do I want to do? Who's got my next suggestion? What do I want to do?
Combine like terms?
Yes, combine like terms if I had them. Don't. So what's next? What do I have? What kind of answer do I have? In this red box here, what is it in general in terms of math concepts? Is it a fraction?
But you have,
Is it a fraction?
yeah, you have a fraction.
Do I have more than one fraction?
No.
Yes, I do. X is a fraction.
Oh, yeah, you could break
I
it
have
up. You
two
could break up the
fractions.
fraction.
So what do I always want when I have more than one fraction in my answer?
Put it into the bigger term.
A single fraction. That's right. Single factored fraction. So what am I going to get? I'm going to get x times 3x to the 4th plus 1 minus x squared plus x to the 5th minus x, all divided by 3x to the 4th plus 1. And now tally, yes, combine like terms. Let's gather things up if we can, right? So I get 3x to the 5th plus x minus x squared minus x to the 5th plus x all over 3x to the 4th plus 1. Every time you do Newton's method, make sure you clean up this process. Make it look pretty. I know pretty means not the same thing for a lot of us, but So what do I get? I get 2x to the 5th minus x squared plus 2x all over 3x to the 4th plus 1. And there it is. That's my...
And that would be the true value at
This is
where
the tangent line hits the axis, yeah. So
Exactly.
this is where the tangent... So if I make an initial guess like 0.7 and put this in, it's going to tell me where I hit the axis. So
this is where if we weren't stuck using dinosaur calculators in 2022, the calculator would give like an actual complex fraction answer,
Yep.
or all put together and
Yep.
give you a real answer instead of
exactly.
an estimate.
So I'm going to Excel now. You can use any program you want. I just use Excel because it's there. I used to be a real anti-Microsoft person, but I gave in.
Or were you a Google Sheets person?
Yep. But the school uses this stuff, so I can't get away from it. But so this is going to be my initial X column, and this is going to be my X next column. You can call it whatever you want. You can do whatever you want. Don't waste time on a lot of things, right? Just get it done. I'm putting in an initial guess of 0.7 because I got that really close to that on my calculator, right? That's why I picked 0.7. I could try 0.5. Doesn't matter. But this is going to allow... Oh, you're the best. Thank you. Coffee. So initial guess of 0.7. And notice what cell I'm using. I'm using cell A2, right? Is that clear to everybody? I'm in column A, row 2, right? So that's my X value, okay? So my X value that I'm going to be calling on is A2. Usually we use capital A. It doesn't really matter. So in my next piece, I'm going to do that calculation, and I forgot it already, so let me take a picture.
We're going to plug it into our actual like XNext that we found.
Exactly. So I've got 2x. Did I do that right, by the way? Did anybody double check my work? Did I get the XNext correct? Did anybody see if I made a mistake? Because I don't want to do all of this and have a mistake in it.
Well, we'll see if it shows up at 0.
No, I know. I'm asking, did anyone else do the algebra and it worked and you got the same answer as me? I'm not asking you to do nothing. Did anyone? Thank you. Soon? Manish, yes? You did no mistakes or?
It looks good. Yeah, it looks fine.
All right.
It's good.
All right, thank you. Okay, so now watch how I type this. Notice I have a fraction, so I need my numerator multi-term in parentheses, right? I need my numerator. Let me just go back to this. So as I'm typing this into Excel, I want parentheses 2 times A2 to the 5th minus A2 to the 2nd, right? I'm using the caret, right? Plus 2 times A2, parenthesis, divide by parenthesis 3 times A2 to the 4th plus 1 close parenthesis. Does that make sense? Right? Because X becomes A2. It's a little weird to see this A2, but Excel recognizes it as a cell.
Yeah, that's the cell that it's referring to.
Right. So I'm going into my calculator and I'm typing all of that into XNext. So I need an equal sign, okay? I need the equal sign, open parens for my numerator, right? Which was 2 times A2 raised to the 5th, right? Can you see? It's hard. I guess it's a little bit hard to see that, but is it okay? You can see what I'm typing? Yeah.
Yeah, well, if you can zoom a little bit, it'll be helpful, please. I don't know if you can do it.
Let me see.
Like control scroll wheel will work.
Control. Yeah, I don't do the wheel.
Oh,
control
just like
plus.
Spam the plus button in the bottom right.
Oh yeah, thanks. Can I slide it? No. Why is it not letting me? It doesn't.
I think it's just because you're entering the formula, probably.
Yeah, I'm in the formula, so I can't zoom. Let me see if I can.
Microsoft considers zooming in on Excel as like part of the sheet's properties.
Got it. I got it. Okay. XNext. Better? So, yes. So, minus A2 squared. Minus A2 squared. Uh-oh. Yes, I got it. Right? Plus 2 times A2. Oops. Plus 2 times A2. Close parenthesis. Divide. Open parenthesis. 3 times A2 to the 4th. Caret 4. Plus 1. Close parenthesis. So Markins, I cannot zoom that cell.
I can see that top, like, near like the ceiling or something.
Yes,
I can see it.
Yes, thank you.
I'm good, thank you.
And look at what it gives me. What's Jesse's answer? 7244. Look at how quick it gave me an answer, right? But now this is the interesting thing is I want to grab this answer and put it as my X because it's my new X, right? So what column is my X new answer in? It's in column B, row 2. So I'm just going to say equals B2. And it's going to copy that answer down. And now I'm going to just fill down. So I'll do Control D on a couple of these. And I highlight this one and I go Control D. Fills the answer down. Look how fast I got the answer. It took only two iterations.
It's like an iteration formula.
Yeah. Yep.
It'll keep repeating, and given that you have the correct formula, it'll converge.
Right. Now look at my answers. They're all the same after the second answer, right? So I know that's the answer, right? Yes, we're doing some computer science here. Yes, totally. Yes. So, but what's nice about this now is I can start at 0.5. I can just start at 0.5, and now look at how many answers till I got how many iterations did I need? Well, the first one got me 0.68. The second one got me 0.72, and now the third answer gets me there, right? But if I started at 1, which is not a bad answer, it's again third answer, right? So you can see if it works, it works. If it doesn't, it doesn't. And that's going to happen in the project. You're going to see it'll work sometimes and not other times.
Can you click on B2 one more time?
Yep.
Thank you.
Yeah, and it's exactly this, right? It's this guy. That last line is what I wrote into B2 without the red, right? This is in my my B2 cell.
Oh, don't worry. I have extensive experience with banging the desk at Microsoft Excel and putting in bigger formulas.
Yeah.
So some of the rules that Excel follows for PEMDAS is a little bit wonky.
Agreed. So I want to. So you're ready to go with the project. Does anyone have a group that you're working with? Is anyone interested in working in a group? You have do you have a Discord, correct?
I don't think we did for this class, actually.
We have a group meet.
You have a group meet. So you certainly can communicate with each other there, right? If you want to work alone, that's fine. It's not that I don't like people. It's just I feel better when they're not around. It is nice to have a group because you can bounce ideas off of each other, and you know, someone could be the Excel nerd, and you know.
I will sanity check on the group me shortly.
Could someone post the group me again for me right now in the chat if anyone did not join but is interested in reaching out for a project.
Yeah, Professor, could you please zoom out a little bit in this page, please?
Yes, sir.
Okay.
Is anyone working on that? Group me into the chat, please. Somebody.
Yeah.
Oh yeah, I didn't get it into my phone actually. Yeah.
Thank you.
Wait, I might connect on Zoom on my phone really quick. Can you hold the link for a second?
We don't have the link yet.
Okay.
We're waiting. Who's putting it up there? Damn it, let's get
Neil, please.
There it is. Thank you, Efsun. Now, one of the things that I would like you to include in your project is a graph. Okay. In particular, when you don't get a solution you remember part F is like 1, 1, 2, and 3, and in part, Jesse, you missed it? It's there now, Jesse. In the chat.
Yeah,
Oh, he someone just here. I'll copy it and post it again. Because you want to be able to, now that you're in Zoom in your chat in your phone,
Okay.
right? Okay. Thank you, Afsin. Thank you for doing that. Jesse, you got it. Okay. So one of the things I want you to include a graph. The graphs get very, very nasty. So what you're going to use is something called GeoGebra. Okay. So GeoGebra. Let me show you. So GeoGebra. It's like geometry and algebra together. It's a stupid name, but it's not mine. So GeoGebra, okay? This thing is gonna eat up your memory. So don't fall asleep with it open. Your computer will be crashed in the morning, and no big deal. But there's a little search here. Is everybody with me? Everyone okay here? So GeoGebra, and I'm gonna go up here. And when you do some of your Calc 2 things, go here. This is gonna help a lot. When you do your revolutions of solids, when you're doing these very, very complicated things in Calc 2, you want to be able to get a visual of it. GeoGebra is the way to go, okay? In Calc 3, I don't know what you'll use. The engineers will take Calc 3. No one else will. So physicists will take Calc 3. It's multivariable. So you're going to go into 3 space, right? You're going to be looking at things in the world. And then 4 space and 5 space and 6 space, etc. Right? So things that we can't even see. That's when math gets really fun. So I'm looking for Newton's method here. Yeah. And there's 1,000 of them. So you just want to kind of look around and see. Remember, I'm going to be getting multiple tangent lines, right? And it's nice because you can plug in the function. You could do everything. Here's a nice one. Just because I could see several tangent lines to begin with, right? Here's another one here. Because I want to be able to see the initial guess, the initial tangent line, and where it hits, and then rinse and repeat, right? So when I get pretty when I get, a lot of tangent lines, it's hard to deal with it. But this is nice because it's giving me, right, 2 tangent lines with different colors kind of on it, right? Now look at what was my initial guess here. My initial guess was 3, right? Do you see that? The initial guess is 3. And then I had a light orange tangent line that hit at 1.8. And then from at 1.8, I got a darker orange tangent line hitting at 1.4 or 1.4 something, right? So you can see it's kind of nice that it's giving me, right? It's giving me all of those things. I don't know what this does. Oh, I guess I can adjust, right? So there's my first guess. And you can see if I make a better guess, I get a better result, right? So GeoGebra will give you a nice picture of things. You might want to, like when you do one of the ones that fail, part F of the project, you're going to want to, you're going to see the tangent lines do certain things, okay? Instead of getting closer to the answer, they're going to get further away, right, when it fails. And so it's nice to give a picture of that in the project. Okay, so I'm not saying you're definitely using this particular one, but I'm saying this is one of 1,000 of them. Find one that gives you a good picture.
In theory, you could do it in Excel as well.
You could.
It's just a little bit.
It's a lot of coding, but
Excel is a dinosaur.
Everything's a dinosaur. we're waiting for the new group of computer scientists here to change things for us. Please get to work on it, please, everyone.
Everything product.
Yeah. Well, what do you think? Two things. So Wednesday we're gonna start section 4.2. Okay. We'll have no homework due this Monday. I hope that's okay. No homework due this Monday. No class on Friday. Can I get some acknowledgement of that you're all hearing me? I will put out an announcement on Thursday night that we're not meeting Friday and that you are using that Friday class time to work on the project. Okay? If you actually do that, I don't care. Okay?
So the project is due on our final exam.
The day of the final exam. Of course, you can give it to me early. I don't care. It's going to be sent to me as a PDF, right? If you work in a group, make sure that the names of everyone in the group are on there. You can always ask me questions. You can ask me questions at the beginning of class on the project. You can ask me questions via email on the project. You can ask me questions in office hours. Dr. Early has seen the project before, so he certainly could help you with it. I don't mind that at all. Like I said, you could find the answers out there, but just make sure you give me what I want on the rubric, right? I want to make sure you're using technology. I want to make sure you give me a graph, and don't nitpick stuff. Don't waste your time, right? Just get it done, right? And you will discover a little bit of what your calculator does when you're, right? If I hit square root of 2 and I set my decimal place at 3 places, right? It'll do Newton's method. It's programmed, right? It's a computer program, basically, right? So it's programmed in there, to iterate to 3 until you get to 3 decimal places, right? And how do you know you got to 3 decimal places? Well, if you keep iterating, it doesn't change, right? The 3 decimal places won't change, so you know you got there, right? And it's funny, when you do the piece where it fails, it's pretty interesting to think about what's happening when it fails. So welcome back, right? Let's if we're struggling in the class, let's do something different. If we're doing well in the class, let's not slow down. Let's keep up the pace. Make sure you're asking for help. I teach at a community college because that's where I went to school. That's where I finally learned how to be a student, and I was able to get help from my teachers, and that's what I'm trying to give back. What I, after a third or fourth chance at failing everything, I'm trying to, show how much I appreciated what my teachers did for me at my community college. And it was study groups that got me through university. When I transferred to university, couldn't believe how much the teacher would come in and just say, read the book, go ahead. Because they're not there to teach. They don't necessarily. And I'm being a little bit unfair.
Yeah, they're there to research.
They're there to research, right?
Yep.
So you could have
that's
a class.
A lot of universities.
You could have a class with 400 students in it, and a grad student is teaching you, right? So study groups are really the way to go. So that's why I like this project, because if I can get a couple of you to trust and reach out to a fellow student, you'll see how valuable that is. It really is. All right, I gotta shut up. I've been talking for over an hour straight. So, anybody last comments or off soon? You okay? When's the project due? Again, the day of the final exam. Okay, so you have 7. You have basically 7 full weeks. I don't know if our exam is on a Monday or a Wednesday. So 7 full weeks plus a day or 2. Right.
I'm gonna get you on the soapbox, so to say. But how many times did you fail before you succeeded in school?
Basically, in high school, I did nothing, and I passed. Then I tried college. I was going to be a sound engineer. I'm a musician. So I was going to be a sound engineer, but I hated it. Then I was playing in a band, teaching music, and for 6-7 years, struggling to make it. Went back to school, had to basically do 6th grade, 6th, 7th, 8th grade math over. It took me 3.5 years to get out of community college. So I felt like it was a third chance for me, really. You know, when I finally gave, I had to
Yeah.
I had to give in. I had to let go of the ego and say this is bullshit. And it didn't change. It's still bullshit. But I had to finally say, okay, play their game or not, make a choice, right? So I gave in. And when I finally got to around Calc 2, I had a teacher that wow, something happened. Something happened that just, I fell in love with it, you know, with learning and thinking and creating and in an academic sense. I was always doing that as a musician, but, you know, so, but it was a struggle for sure.
It sounds like it, and you know, honestly, it's like a inspirational story almost.
Yeah, I do believe there are plenty of students that were like me that just did nothing in high school, and you know, just like
Right.
this is bullshit, you know. And so, but there's so much in math that I wish we could teach. That's just so beautiful. Like the connection to music is incredible. It connects to trigonometry. So we don't get a chance to often show how beautiful math is in this classroom, but you will see some great things in Calc 2. You'll see some amazing things as you go further, for sure.
For sure.
Hey, have a great day. Good to see you all back again. I like the energy. I love the cameras on. I am in office hours today, so feel free to come back or stick around or whatever you want. Okay? Yes, soon you can certainly do that. Thank you. Have a great day. Let me stop my recording. Sorry.